If all goes well, the screen should be shared by now. So yes, thank you very much, Simon, for the kind words. I'm Matias Madou. I'm the CTO and co-founder of Secure Code Warrior. My history goes back to doing a PhD at Ghent University, where I was playing with static analysis solutions. And with that knowledge, I actually joined a company called Fortify. And I actually moved to the US, joining Fortify. And that was very, very interesting. And I think, these static analysis solutions are really good at finding problems in code. But ultimately, I said, well, it's not kind of hard to find problems in code if you never tell a developer, if you never teach a developer how to write secure code in the first place. So with that kind of mindset, I jumped ship and we started this. And we really wanted to make sure that we give the developer the tools and the means and the knowledge to write secure code from the start. And as Simon was saying, yes, we're running a challenge. We're running a Secure Code Warrior tournament. There's still plenty of time, so don't go away. There's still time to check out this talk, for example. It's in line with the conference, so it was 24-hour challenge and a tournament. If you want to know how to participate, go, for example, to the Secure Code Warrior Slack channel. And there's even some prizes that you can make with that tournament. If you're the first prize, you can get a $200 gaming voucher. And I just heard that Fortnite had another event, so maybe that you can use it for that. So the agenda for today. So first of all, I would like to talk about, why are we still here? Why are we still talking about security? Why is it impossible to write secure code? And then I would like to, focus on the software security person. What is he doing? More what was he doing, hopefully, and what should he be doing on a day-to-day basis. And then I would like to take DevOps, and I found a very interesting way to look at DevOps and how can we get security into DevOps? How can we get security in the culture, in the automation, in the measurement, and in the sharing? And ultimately, I will come to a conclusion. And hopefully there's some time for QA. So why are we still here? So we all make mistakes, small one, big ones. If you look at a very big one, then the Ariane 5 rocket, well, within a minute after the launch, they had to self-detonate the rocket. And with the self-detonation, $7 billion was lost and also 10 years of work. What they actually tried to do was fairly simple from a coding perspective, a very simple mistake. They tried to cram a 64-bit float into a 16-bit integer, and they said, what, for performance, let's suppress the error handling, and that caused so cramming that into a 16-bit caused the overflow, and the error handling was not there. So ultimately, instead of going forward, the rocket had to go backward, and they had to self-detonate the rocket. Mistakes happen. Imagine being the developer, and this is your code where you try to do that. But hey, out of something bad comes something good. Lessons are learned. NASA said, what, how can we prevent something like that? And the way they did it was they said, what, from now on, we have to be very, very cautious with every line of code that goes into these rockets. We only have one chance, one faulty line, and we're done. So they put a lot of things in place, and they bumped essentially the cost of every line of code to $1,000 a line, where the average cost around the same time was $50 a line of code, and they were able to prevent that. Yes, it's expensive, but imagine what you could do with the amount of money and the time you also lost with the previous mistake. Unfortunately, I saw that my video didn't work here. The sound didn't come through. But as Bob Ross would say, we do not make mistakes. We only have happy accidents. I'm very curious if that developer had the same reasoning the day he found out that his code caused the Ariane 5 rocket blow up. Anyway, sometimes bugs become essentially features in our solutions. Let's have a look at, for example, the most known thing is Street Fighter 2. Street Fighter 2 is immensely popular, or was immensely popular. And it would not have been popular if it wasn't for the combo. Ultimately, the combo was, well, initially a glitch. A developer figured out that, hey, you could hit a person twice and it would count as one. So they elaborated on that glitch, and essentially that glitch became a nice feature in Street Fighter 2, which made it immensely popular. Another very interesting feature that we have these days in our applications is the feature where external people can execute whatever query against our database. They can alter our data in the database. They can remove entries out of the database, all at their own leisure. Of course, this is not a feature. This is SQL injection. And we're still talking about SQL injection. Why are we still talking about SQL injection? Because even this frame was received by me, by my manager. I got that from my manager back in the day when I was still at Fortify. And the interesting part is the back. It is signed, "Hey, Merry Christmas, Matias." It's from Jacob, 2008. That's 12 years ago. That is 12 years ago. And that was not new 12 years ago. That was already 10 years old in 2008. So we're still talking about something that is 22 years old. Why is that? So let's have, first of all, a look at numbers. I love numbers because if we have to go with my opinion, that would not be good. So let's go with the numbers. 1 in 3 newly scanned applications had still SQL injection in the last 5 years. Well, the joke goes that 2 out of 3 do not have a database. 111 billion lines of code are written by developers every year. We're all software developers, right? Who's the software deleter in your organization? Very hard to find that particular person. We want to create more features. We want more. Customers want more. We all want more. We write more code. 30 times more expensive to fix a problem early on than later in the cycle. You know, what we do these days is we wait until it lands into our bug tracking system and we only fix one out of 30. Well, maybe there's a different strategy that you can deploy in your organization to fix essentially all vulnerabilities. And the average cost of a data breach, almost 4 million. Why are we still talking about this particular problem? Why do we still have SQL injection? Well, this is an oversimplified way of what we're doing today. If we have a concatenation of 4 parameters in a query, and our pen testers come back and they scream and they say, "Oh my God, we're vulnerable to SQL injection. We even saw a couple hacks on our platform. Parameter 1 and parameter 2 are vulnerable to SQL injection." Well, then instantly the developers are mobilized and they have to fix the problem. If our static analysis solutions come back and they say, "Well, if all the stars align and if everything goes right, then potentially parameter 3 is vulnerable to SQL injection." What quite often happens in that scenario is, well, you start a fight between QA, security, and developers to figure out if it's really a problem or not. Sometimes the fix is even easier to deploy than the whole discussion around trying to find out if this is really a problem. And last but not least, if nobody can tell today that parameter 4 is a problem, if none of our tools, none of our pen testers, none of our internal people can figure out if parameter 4 is a problem, well, we are not going to fix that because it works. It works. It's perfect. First of all, well, quite often we do not know if it's really safe because there's so many paths in the application that can lead to that parameter. But second, even tomorrow or next week or next year, a new developer can come on board and add some new parts in the application, and parameter 4, where it is safe today, becomes vulnerable tomorrow. This is how we treat application security today. We're not going back to the root cause, which is, hey, let's make everything safe from the beginning. And why is that not safe? Why is this not all going well into today's world? Well, let's look at what we do on how to fix problems in code. Well, first of all, I've never seen an empty bug tracking system. There's always problems in a bug tracking system. If you find one, let me know, by the way. And we asked the developers, hey, can you fix the security issues? All these security bugs, can you fix them? And we help the developer with giving almost nothing. We say, Google it, Stack Overflow, whatever, figure it out. And we ask them to fix the problems. Sure, they can rely on the application security team. Unfortunately, there's one person per 100 developers that has to guide and steer the development team, the developers. So 1 in 100. Think about 100 people. Have you interacted with 100 people this month? Can you enlist 100 people that you've talked to in the last 3 months, 6 months? I don't know. 100 people is a lot of people. And imagine that you have to guide them on a day-to-day basis. You're responsible for the security for the code that they are writing. It's nearly impossible. There's also a ton of overhead. If you fix a security issue, there's a ton of overhead in trying to find. You take the bug, you find a solution for the bug, you implement a solution for the bug. You have to test it yourself. It has to go to QA and so on and so forth. So everything that you fix causes a ton of overhead. Quite often, also developers and security, they kind of speak the same language. They kind of do not speak the same language, of course. The developers speak about languages and frameworks and coding techniques, while security people, they talk about, breaking this stuff and not giving answers to how to fix it. Essentially, all that the security people have to do in the old days was just show that it is broken. Even if they do not see the code, if they do it black box, they attack the application, they show that it is broken, and it is the developer, it's his problem, or her problem. That is why they speak a different language. So ultimately, we fix a couple problems, but not all of them. As I said earlier, maybe 1 in 30 security problems, I don't know. Second, we keep on introducing new code. As you saw in the previous slide, we create billions of lines of code. So on a daily basis, we introduce new problems into the code. I once did an analysis of an organization, and every developer in that organization caused $50 of ultimately problems that another person had to fix. And that's actually normal, because there's 700 different categories of problems. So these static analysis solutions can find 700 different categories of problems. So with more code comes, of course, more bugs. And then there's the stuff that we do not know, that nobody knows of, that nobody finds. So ultimately, it's a never-ending story. So what does a security person, AppSec, DevSec, software security, name it, what does the security person have to do? Well, if we look at what a software security person has to do, well, in green, you can see that he should deal with, tough security questions like, hey, how can we make sure that throughout our organization, if we create code, that that code is secure? Unfortunately, quite often they are very distracted with other stuff, and that's mainly because they are understaffed. There's only one person per 100 developers, so it's hard to make sure that everything is moving into the right direction. Luckily, there's quite often a good budget for AppSec, because companies are security aware these days. They want to do the good thing, and as my good friend would say, more money, more problems. So we can throw more money to our problems today, but unfortunately, that's not always going to work, because we keep on creating more code, which is causing more vulnerabilities. So ultimately, more code, more problems, we have to start understanding the code. As an AppSec person, as a DevSec person, we have to make sure that we really, really understand the code. We have to move away from just finding the problem and not fixing the vulnerabilities. Breaking, we're not the builders. We have to move to, we as security people have to understand code, that we can help the developers what they're doing on a day-to-day basis. It's no longer just breaking this stuff and leaving them behind. No, we have to understand the code. So how can we do that? How can we create secure code today? Well, there's a lot of different methodologies, right? We moved on from waterfall. Quite often I ask the question, did we really move on? Because I still see it quite often. We try to do some agile methodology. We want to make sure that it goes faster. We're closer to our customers. We do things in rapid sprints so that they can test and see if it's working for them. And ultimately, DevOps, where we have that continuous loop, where we want to make sure that we have that feedback from operations. And I think over there's a real opportunity to bake in security. And how can we do that? Well, a developer, he already has a job, remember, and it's writing features. So we cannot ask him to type faster, harder, doing more hours. No, we have to make sure that he can work smarter. He doesn't have to work harder or faster, but we have to work smarter. So I think there's an evolution from waterfall to agile and DevOps. At the same time, in security, we have to think how we can make sure that we can ride that same wave, that we can make sure that our security processes or tooling or training, everything that we do in security follows that same trend. The opportunity is clear. I think there's an opportunity to, around developers, create an environment to write secure code. I personally think that there should be an environment where everything that a developer does, we as security people have to integrate with their solution and help them on their platforms. If they are working with IntelliJ, if they are working with Visual Code, well, we should help them over there. If they are on Slack, if they, wherever they are, we should be able to integrate with their solutions. I think that is the most powerful thing. At the same time, also from a security perspective, we have to make sure that we tap into the operations side and that we bring that knowledge to the developers. That gives them visibility into what's really happening. And I think there's a real opportunity, and maybe there's even some room in that loop, in that DevOps loop, to train people and assess people to get them better every time, and making sure that they create secure code from the start. So DevOps, what are the pillars of DevOps? Well, I did a quick Google search, and it seems to be between 3 and 9. I think nobody can really tell what the pillars are of DevOps. Well, I didn't find a concise answer. So that gives me a little bit of a freedom to look into all these pillars and pick something. And one that I particularly like was Calms, which transformed to Calms, but I'll start with the original one, which is culture, automation, measurement, and sharing. So in Calms, to have DevOps right, we have to make changes in the culture, in the automation, the measurement, and the sharing. I'll leave that as such, but my question is, how can we, from a security perspective, make sure that we embed ourselves into the culture, into that automation piece, into that measurement piece, and into that sharing piece? So let me go through that. So first of all, I think it has to be a change throughout the organization from a culture perspective. We have to move on from all that reactive stuff, and we have to be proactive. If you think about building a house, it is not when the house is done and you're ready to move in. If you discover at that point that all the wiring is faulty, well, you have a really, really big problem. You almost have to start from scratch. But this is where we are today. We have a lot of pretty shiny applications, but if you look under the hood, quite often they are just from a security perspective an entire mess. And it's not really the developer's fault. It has a lot to do with deadlines and delivering and making sure that the customers are happy and delivering features. So if it doesn't come from the top down, it's not going to happen. So from a culture perspective, it is not the developer's fault. He has to be given the time to make sure that the security piece is right in that organization and in that application that he is creating. So we have to make something that is relevant for developers. If we want to help the developer in writing secure code, we have to make something that he really loves, okay? And that can be, online, hands-on, gamified, tailored, It has to be something that a lot of developers like and love. At the same time, making a platform that is gamified without some substance is not going to work. Neither is it going to work if the developer does not see the benefit of why he should do that. So a developer should understand that if you always write secure code, what we see is that you're really above average. There's definitely a clear correlation between a good developer and a security savvy developer. And my personal reasoning over there as well, you start by just creating something as a junior developer. Once you do that, you learn more about, hey, how do I build software? How do I do stuff? And when you learn everything, when you learn a lot, ultimately you need a new challenge, and you're going to ask yourself, well, how does that security piece work? And how do I build secure applications? So it's not something that you start straight off, but ultimately you roll into. So if you want to be, if you think like, hey, I want I want to be a highly sought after developer. I want to work on projects that require good developers with a security mindset. Well, think about security. Think about, hey, how can I upskill myself and make sure that I always produce secure code? Ultimately, the company has to rally around like, hey, there's only one type of good code in our organization, and it is secure code. Has to be a cultural fit. Why is Duolingo doing really, really good versus old school in-class training? Well, it appeals to a younger generation. They want to learn in a particular way. They want to take their mobile and learn a couple words. Even my kids are doing it. They want to learn another language. Well, they're on Duolingo. They learn by just doing. If I would say, you have to, they do not particularly like school, but Duolingo, they quite often are on Duolingo without me asking to do that. School is a different thing. Second one, automation. All too often with automation, I see security tools being deployed into an organization where it truly does not fit. One group has done a test with a security solution. They bought it. It organically grew in that team, and now they want to deploy it to the entire organization, but the entire other developers are not on the same stack, and they still want to implement that, or it's not doing the right thing for them. So if you do that from a security perspective, you have to make sure that developers are on your side. You want to help them. You really want to make sure that you give them something that shows benefit to them. So if you're going through tools, if you're going through something that you want to buy for developers with a security angle, you really have to make sure that it fits the technology, it fits the stack, it is relevant for what they're doing. Automation, it's all about, you want to make sure that as many security tests are executed as often and as frequent as possible, but not too many security tests. And what that means is, if a developer goes away from his desk and he say, now I want to build my code and I want to test my code, by the time he has grabbed the coffee and comes back, the test should be done, and he should have a result. I've dropped 5 minutes on there. It can be 2 minutes for your organization. It can be 10 minutes, depending on how long people take a coffee break. But you know what I mean, right? You do not want to stop the developer. And you cram as many tests in there as possible. And all the tests that do not go in there, you either parallelize the rest or you drop them into a nightly build. Maybe a controversial one. For security people, well, we do not block the build. We do not block the release. You should really get everything into production, only if you're really, really sure that something is not right from a security perspective, then you stop them. If there are security credentials that are going live, then you definitely should stop them. But you have to make sure that if you stop them, you stop them for the right reason, because that happened all too often back in the day, right? We blocked all too often developers, and afterwards we said, "Oh, sorry, this was a false positive. It's our tool." So if we implement something, we should think from a developer perspective, and we should be really, really sure if we stop or break the build. Developers, chat ops. In our organization, developers no longer read email. They are communicating in a different way. And I think from a security perspective, we have to look into what these new ways are that people are chatting with each other. So we have to integrate ourselves. Again, we do not have to force ourselves and say, now you have to read email. No, if they are using Slack or whatever, we should integrate from a security perspective with the way they want to communicate. And last but not least, if we're spinning up containers for security, we have to make sure that they're really standalone containers, because ultimately, if there are dependencies and another container goes down and we have some dependencies from a security perspective, they will point the finger rightfully at the security people broke it again. Measurement. It's a really hard one. How do you measure security? I think there's been numerous books and papers, academic and white papers written about how to measure security. It's really, really hard. But the way I would like to think about that in the new world is we have to think about the end goal. And the end goal is that we want to ship in a reliable way software into production. That should be the end goal. We have to make sure that our customers are happy with our solution, that they see new features, that they can use them, that they are good. So that is our end goal. And security should align with these goals. And security should not have goals that contradict that ultimate goal over here. So what is important? I think speed of delivery is very important. Speed of going to market, speed of getting something into production is really, really important. So we can measure a lot of things in DevOps. And from a security perspective, we have to think, where can we help? And there's stuff that we should avoid. We should help with deployment frequency, with lead time, and so on and so forth. So they're really good things that security can help. Where one thing that we should not measure is the mean time to failure. We actually want to fail. We want to fail fast. We do not want to lengthen the time in between two incidents, because that will have an inverse effect of what we're trying to do, because you will only make it worse. No, what you really want to do is you want to find the problems, you want to tackle the problems, and a good measurement is, if we're failing, how fast can we recover? So we want to make sure that you can recover very fast. Make sure that you measure the right thing, which is, hey, making sure that we are back up and running, not trying to lengthen the time in between failures. Because again, that contributes to our end goal. We want to ship reliable code. And last but not least, sharing. What is sharing and what it is and what it is not? I think maybe back to my title, AppSec is dead. All too often, I see application security as the people with the papers. They write endless documents. They write coding guideline documents. They write documents for everything. Well, unfortunately, that is not how you reach a developer. You do not reach a developer by writing endless documents on how to do security. It has to be in technology. It has to be into the frameworks, into the tools that the developer is using on a day-to-day basis. And think about this one. What happens when a developer fixes a security problem, and let's say the day after he leaves the organization? So a problem has been found. We've located the problem. A developer sits down, looks for a solution, looks really hard for a solution, finds a solution, he fixes a solution, and he checks us in. He checks his new code in. And he closes the bug. And the day after, let's say he moves on to another organization. That knowledge is unfortunately gone. Yes, it is fixed on one line of code or two lines of code. It is fixed in the application. But that knowledge is ultimately gone. It is not populated to the other developers on how that fix worked. We didn't look for other places in the application where that same problem occurs and where we could have fixed that. That information is all gone. And that happens, unfortunately, quite often. And it does not help by, as a security person, to go there and document the stuff and send an email to all the developers and say, hey, you know what, this is what we've done. This is a point in time. It doesn't help. We have to share this with the technology means. So the way I envision sharing what is coming is really, we identify a problem with whatever application security testing tool. An AppSec person helps the developer of fixing that particular problem. But then we capture it. We capture it in technology. We capture it in the IDE. We capture it in our source code repository. We capture that knowledge so that we never ever make a similar problem in our code again, or we actually remediate other problems into the code. And I think that is really the future for sharing. If you think about intelligent security sharing, I think it has to be through technology. So I come to the conclusion of my talk. I was able to explain why we're still here, why it is still impossible of writing secure code. We've seen throughout history that we've made a lot of mistakes. We always try to learn from these mistakes. And I also think we have to learn and tackle the problems that we have today. We've seen that a security person today is quite understaffed, and as a result is not always busy with the code and is busy with other stuff. I think the software security person really has to be very close to the developer. He has to intimately involved with the code. He has to understand the frameworks, the technology, the tech stacks that they are using. Then I hope I was able to show how security can help from a culture perspective. So if you're already doing a shift in culture, where does security fit in? How can we do some automation and not disrupt the developer? How can we blend in with the regular automation that is happening, but then from a security perspective? What are good things to measure from a security perspective? We should not measure or lengthen the time between failures. We have to make sure that we recover fast. And I think ultimately, from a security perspective, sharing happens in the tools and the technology that a developer is using. With that, I would like to conclude my talk, and I was wondering if there are any questions, Simon.
Okay, we have a question. Farshad Abasi asks, how do you share through technology? Adding issues to GitHub is just another place where they're documented.
How do you share through technology? So one thing that I really like is in the IDE sharing, and I'm happy. So I'm sorry I didn't catch the name, but please ping me over Slack, and I'm happy to show you a couple things on how you can share through technology. There's nifty technology out there where you essentially, through rules, through customization of existing tools, can capture your knowledge, find similar problems, and fix similar problems.
Awesome. I've got a question actually around measuring, I guess. So in terms of things like, Source Code Warrior, obviously there to kind of like really help kind of level up developers going forward. How do you measure these kind of things? Is it simply through vulnerabilities that are found either before production or after production, or how is that kind of like ROI?
Yep. Yeah, so that's a very good question. So the way, and I think personally that's what I really like about the solution that we roll out in organizations is we work with the organization, with the company, and we ask, what is your problem? If you have your pen testers, your static analysis solutions running, does it come back with always the same thing? And quite often it does. Quite often there's the usual suspects like SQL injection and cross-site scripting. So they're aware of what their top 3 vulnerabilities are. What we then do is we put a program in place where we specifically focus on these 3 problems, these 3 vulnerabilities. And we are going to roll that out in an organization and say, hey, you know what? This year we're going to make work of SQL injection, cross-site scripting, and LDAP injection, whatever. At the end of the year, we're going to look at scans again, and we're going to look at the pen testers again, and what we see, of course, over there. So we're not doing the measurement in our solution itself. We can, but we love to do the measurement on the real things, on what is produced by these developers. Because that is ultimately what you want to measure. You kind of want to measure how often do people visit our platform, or how often do they interact with our solution. That is a means to an end, because the end game is you really want to measure, did I see a reduction in the top 3 categories that I really wanted to tackle this year?
Awesome. Another question coming in from Hamad. Why is the culture not changing?
Why is the culture not changing? So why is the culture not changing? I'm not sure what exactly that refers to, but quite often, that is a pretty interesting one, but quite often an organization has to have an incident before the culture changes, There's even companies in recent history that had to make announcements, that they said, right now we really have to we have to invest in security. We didn't do before, but we have to do it. And what causes that trigger point is really a public problem or a security problem that becomes public, and that quite often is embarrassing for them. So what triggers if quite often they are underspending in security. If they're underspending in security, what we see is there's not a whole lot that you can do as a developer, unfortunately, or as a security person. There's not much you can do. Hoping for a security incident is kind of ugly. You can't hope for a security incident against your organization, but ultimately that's what you have to wait for. If there's a security incident, then the eyes go open. That's one thing. And the second thing is if they break into your neighbor's house, that's when you realize you have to do something yourself too. So if you look at your competition and your competition has been hacked or is going under because of a hack, that's when normally the eyes go open and they say, oh my God, we have to make sure we're not the next one.
It's a bit like an outage kind of thing as well. Like, what is the cost of an outage? How do you measure that? And what is the cost of a breach or a hack? Or it's an extremely hard thing to kind of like foresee, right? But that's awesome.
It's when do you install a burglar alarm? I have it.
Very often,
not a lot of people have it.
The cost of the burglar alarm, just in time or money in actually installing it, is it's not insignificant, but it's do
smoke alarm then. Do smoke alarm. These things cost you $10. And it I have them, but quite often people do not have them, or they're too late in having them.
Yeah. One last question before we conclude. Mohammed asks, what are your thoughts about maturity of open source tooling to support the automation you referred to in your presentation?
Open source tooling. I'm a big fan of open source. It always sparks some interesting ideas that quite often then companies are built upon with, I have to say, better support. So I always like open source, and there's always good stuff in there. Unfortunately, quite often there is not the support layer around it. And quite often you see commercial companies then picking that up. But I really like open source, and there's some really good things out there that are still, cutting edge, very relevant. And if you're an early adopter, you definitely should go with open source. Okay. That means you're also ahead of the curve, I think.
Mm-hmm. Awesome. Matias, thank you so much. Great talk, and thank you very much for joining us. And as well, thank you Secure Code Warrior for being platinum sponsors. So we really appreciate your support of the community as well as the conference.
Absolutely. Thank you very much for having me, Simon.